Module 5, Overview of Management Principles for Habitats and Species. In this module, we give an overview of habitats and species management, with particular focus on the management of grasslands, peatlands and woodlands. Best practice management guidelines are described, which aim to improve habitat condition. The ecological management of habitats and species requires the management of the entire ecosystem. As a result, we focus on ecosystem management, which is the application of ecological science to resource management, promoting long-term sustainability of ecosystems and maintaining their structure and functions in order to deliver essential ecosystems, goods and services on which we depend. In taking an integrated approach to ecosystem management, we consider a range of goods and services and manage in areas cognizant of their interactions, trade-offs and synergies. The integrated ecosystem approach also takes into account the characteristics of the ecosystems in terms of its political and social setting. The approach integrates social and economic information with biophysical information and explicitly considers the provision of human needs. The guiding principles behind ecological management are promoting long-term sustainability as a fundamental value, ensuring clear operational goals. Sound ecological understanding underpins ecological management and an understanding of connectivity and complexity. There's a recognition of the dynamic character of ecosystems and attention is paid to the scale and context in which the ecosystem is situated. It includes humans as a component of the ecosystem and incorporates principles of adaptive management approaches. There are a number of general management techniques and guidance that is applicable to most habitats. They can be divided into 4 key areas. Management of different taxonomic groups and taking into account their habitat requirements, understanding the influence of landscape factors, the importance of grazing regimes in regulating vegetation composition and structure and control of unwanted species, such as invasive species control and control of predators where there is an imbalance within an ecosystem. Many species coexist within an ecosystem. Conflicts can arise between the management requirements of different groups. However, these are usually rare, and habitat management generally involves maintaining groups of species that coexist together. In managing for plants, we are generally aiming to maintain or create conditions that support high species diversity or support rare or endangered species. As a general rule of thumb, intermediate levels of disturbance in terms of grazing, cutting, treading, and intermediate levels of fertility support the highest diversity. However, certain species associated with low nutrient levels are increasingly rare, and a certain level of bare ground is also needed for germination of particular species, but excessive levels indicate high intensity of use, which is detrimental to species survival. Certain rare and species of invertebrates are habitat specialists, and their larvae and adult life stages further complicates the situation by having different habitat requirements. Due to their size, invertebrates generally utilize certain features or microhabitats within larger habitats. So diversity within a habitat creates a broader range of conditions supporting a greater diversity of invertebrate species. For bird species, habitat structure is a major influencing factor in terms of habitat suitability, determining the abundance and accessibility of both food availability and nest sites. Landscape factors, essentially the context in which a habitat is situated, can influence the species that occur there. Landscape factors include factors such as area, with many species requiring relatively large areas of suitable habitat to sustain viable populations. Species generally occur at larger densities and larger habitat patch areas. Connectivity between habitats is an important factor and influences the ability of species to disperse between areas, and corridors are important features along which species can disperse between larger core areas. This can be a double-edged sword, however, when you want to encourage dispersal of rare and threatened species where there is an invasive species which you don't want to disperse across the landscape. Edge effects are important in smaller areas with large edges to core ratios. There may be not enough suitable habitats to support viable populations. Conversely, certain edge types, buffer zones as a particular example, help to reduce negative effects of surrounding habitats on core conservation areas or aquatic ecosystems. Good quality surrounding habitat can act as a source area for colonization and spread of species into newly targeted restoration or rehabilitation areas. Essentially, in terms of landscape factors, context is everything. In many of the habitats of nature conservation importance on Irish farmland, you will see that grazing is an important ecological management tool. Grazing animals determine the relative abundance of species within an ecosystem. They can have a direct influence on the vegetation structure, and the different grazing behavior of different animal types, coupled with the relative palatability of species within a grazed area, has a major influence on the resultant vegetation structure. Relative palatability of species also changes with season, so the timing of grazing is a major influencing factor on the degree of vegetation utilization or removal resultant from grazing. Grazing animals also indirectly influence habitat condition through the effects of trampling and poaching, which which has a particular influence on microhabitat for invertebrates and in turn the species that feed on them. Grazing animals also have an important role in redistribution of nutrients within the ecosystem. In summary, the overall grazing regime in terms of animal type, grazing period and intensity that an area is subject to is reflected in the resultant vegetation composition structure and diversity of microhabitats. This knowledge of the interaction between ecological management, ecosystem structure and function informs the design of results-based scoring systems. And the main drivers behind the categories of results indicators can be summarized as follows. So in terms of ecological integrity, the main factor that influences the presence of positive indicators and negative indicators and their overall abundance is vegetation management or removal through grazing and cutting regimes, and also the nutrient management, which influences the overall soil fertility. Management intensity relative to the carrying capacity of the land is a major influencing factor over the percentage of bare soil or erosion in terms of the soil integrity and variables that are usually included within results-based scoring systems. In terms of hydrological integrity, the main management factor that drives this is the drainage past and current drainage characteristics of the land that's being scored. And essentially, with the damaging activities, this is essentially provides an early warning system to avoid poor practices and highlights the influence this can have negatively on ecosystem condition and the resultant score and payments that a farmer can receive. So this knowledge of ecological management that we've looked at in this presentation informs the management guidance that should be given and the supporting actions that should be selected in hybrid results-based agri-environment climate measures. The ACRES system also includes a range of supporting actions, non-productive investments and landscape actions, for example, including invasive species control, hydrological management, grazing infrastructure, scrub control, and a number of specific species actions for birds, for example. Planning the right measure in the right place is essential, and this is informed by the scoring system coupled with knowledge of the farm context. A key protection mechanism within Natura 2000 sites, or special areas of conservation or special protection areas under the Birds and Habitats Directive, is a requirement to consider the possible nature conservation implications of any plan or project on Natura 2000 site network before any decision is made to allow it to proceed. The CAP strategic plan is subject to appropriate assessment, which has been carried out as part of the CSP process. The resultant Natura impact statement reviewed the potential risk of adverse impacts arising from the proposed implementation of the draft CAP strategic plan and found that without the implementation of mitigation measures and recommendations, the draft CAP strategic plan would have potential to impact upon the integrity of European sites. Appropriate assessment screening is the first step in appropriate assessment and is a preliminary assessment whether an activity could have a significant effect on a Natura 2000 site, taking into account the site's conservation objectives. The Department of Agriculture is the competent authority with legal responsibility for appropriate assessment of the CAP strategic plan and associated interventions. Appropriate assessment is part of the mechanism to ensure the right measure in the right place. The rest of this module focuses on a number of habitat case studies, taking into account taking you where you will see some of the general management guidance and techniques applied in a specific circumstances. Thank you.